the strength of a synthetic fiber that's possibly affected by the percentage of cotton in the fibers being investigated. We have three percentages of cotton, 15, 25, and 35, and what we have are measurements of tensile strengths for the random samples of fabric with each cotton percentage. We have the data and we want to use it to find our sums of squares that would be needed to perform an ANOVA. What we're going to need to find our sums of squares are means within each group and our variances within each group, and then also what's the sample size for each group. I'll just provide those here, and I'll let you double check using the methods learned earlier in the class that these are the correct means. So the mean of the first group of data, 7, 7, 15, and 11, is 10. The variance of that data, so our S1 squared, is 14.667. And the sample size there then is equal to 4. For our second group, we have a mean of 16.833, a variance of 3.767, and our sample size for that group is equal to 6. And then for group 3, the mean is 22, the variance is equal to 9, and our sample size is 3. Our n is our total sample size, so 4 plus 6 plus 3, giving us a total of 13. We're also going to need our overall mean x bar, which we obtain by taking each of our sample sizes times our mean from that group and adding them together, and then dividing that whole thing by our total sample size, which we just said was 13. And what we get for our overall mean, which would be the mean of all of the data, is 15.923. So now we have the info we can use to find our sums of squares. Our sums of squares between is where we're going to take our sample size for the first group, which was 4, times the mean from that group minus the overall mean, and we square that term. And we do this for each of our groups. And so what we get for SSB is equal to 256.086. Our next sums of squares within, measures how much data there is within each group, and what you do is take sample size minus 1 times your variance, and then you add them all together. And so what we're going to get for this one is 80.836. So sums of squares between measures how much variance there is from group to group, because we have different groups. Sums of squares within measures how much spread we have within our groups. And then the total is just adding those two together. So if we take 256.086 and add that to 80.836, we get a total sums of squares of 336.922.